Hi, I'm Ben McEwen, and I'm a compositing supervisor and VFX mentor. I started my compositing career using Nuke in 2011 and have worked with many studios since, including Rising Sun Pictures, Method, Oat Studios, DNEG, ILM, and I'm currently a compositing supervisor at Image Engine in Vancouver. I'm also the author of Ben's Comp newsletter, a bi-weekly newsletter designed to help compositors stay at the top of their game and rapidly advance their careers. I started Ben's Comp newsletter in January 2018 as a way to both share and solidify the knowledge I'd gained throughout my career with others. I noticed that there were plenty of 3D-based websites revolving around showcasing people's work and learning resources for myriads of 3D disciplines, but there weren't and still aren't really that many resources out there for compositors. Throughout my career, Ben's Comp newsletter is something I would have massively benefited from, so I created this resource for others who are hoping to rapidly develop their compositing careers as well. Subscribers to the newsletter receive the best gizmos, Python scripts, workflow tips, and in-depth knowledge on compositing techniques to help keep their toolsets and skill sets at the forefront of the VFX industry. I hope it encourages open communication and knowledge sharing between the global compositing community so we can all grow better together. As you might have gathered, self-improvement and continued learning has been a huge focus in both my life and my career, and I'm always encouraging others to choose this path as well. I often hear compositors mention some flavor of, "I really wish I knew Python," and since you're watching this webinar, I presume that's been you at some point recently. Don't worry, I used to be one of these people too, but one day with no prior programming experience, I decided to take action and teach myself. As a complete beginner, I was trying to piece together knowledge from various blogs and YouTube videos, and I was also attempting to go through Foundry's Python documentation. And whilst it's really good documentation and makes a lot of sense, with no prior programming experience or any context for what I was even trying to achieve, this way of learning proved pretty difficult. Although ultimately, through years of trial and error and just figuring things out on my own the hard way, I gained a level of decent competence which opened up a world of efficiency in my work, both as an artist and a supervisor who uses Nuke daily. So how exactly does Python benefit compositors, and why should you learn Python? Well, under the hood, Nuke is built with Python at its core, which allows for a robust amount of programmability and customizability. This programmability benefits compositors who are conscious of not wasting time on menial tasks, but instead are willing to harness the power of simple customization and automation to take care of the laborious tasks and ultimately free up more time for the fun and creative work. The scope of what you can achieve with Python is massive too. From small things such as renaming nodes or force reloading all read nodes in your Nuke script, to developing entire pipelines and even entirely new tools from scratch. It's hard to understate how much of a difference customizing Nuke to work the way you want to work is. Even seemingly small things like changing knobs' default values and customizing menus to work the way that your brain thinks means small amounts of time saved each time, and that accumulates really quickly over the course of a day or even an entire project. Today, I want to show you what's possible in Nuke with even a basic understanding of Python. This webinar is primarily about enhancing productivity and efficiency in Nuke as an artist, and Python is just the tool we're using to achieve this. Because Nuke's spine is Python, artists using it can control almost every aspect of it programmatically. Now let's jump over to Nuke and I'll show you a couple of things. So by enabling echo Python commands in our Nuke preferences and keeping the script editor open, watch what happens when we do anything. I'm going to create a grade node here and see how in the top of the script editor you can see it says nuke.createNodeGrade, and even copy pasting this node outputs code as well. The fundamentals of programming in Nuke are about understanding what's going on under the hood and harnessing that knowledge to do what you require. How you improve your workflow in Nuke is a really personal experience. Think about tasks that take you a long time to complete, or even small frustrations in the way that Nuke works that you'd like fixed. These are perfect candidates for your first step in Python. For some inspiration, there are tons of Python scripts available on Nukepedia which you can easily install and can add to your own menus. Let me show you how you can do this. When programming, you'll often write code in an IDE, which stands for Integrated Development Environment. IDEs offer features such as syntax highlighting and certain shortcuts which make writing code easier. A few popular options include PyCharm, Atom, and Sublime Text. Although I often like to test small chunks of my code as I write it to make sure each section is working as expected in Nuke script editor. While the script editor runs the code, it doesn't actually have any of the nice features that these dedicated IDEs have, and this makes it harder to debug erroneous parts of my Python scripts. Adrian Pueyo clearly had this same frustration, so he wrote his own Python script editor using Python directly for Nuke. Super meta. So we're going to install Knobscripter as a demonstration of how easy it is to get any Python script from Nukepedia and install it and get using it to improve your workflow. You can download Knobscripter from Nukepedia. You'll have to log in first before it will give you a download button. And here we go. We can go and download it. You have to agree to the terms and conditions and save it. So we have two folders open here. One is our Knobscripter zip file and one is our .nuke directory. Now when you open Nuke for the first time, it creates this .nuke directory inside your user directory. And this is where a bunch of files live that Nuke needs to operate. One of these files is a menu.py. And you might have heard of that before, but a menu.py is a Python file itself which holds Python code that executes every time Nuke opens. And we use the menu.py to do all sorts of things. If you're interested in learning more about a menu.py and the basics of what can go in there and how to use it, you can go over to my blog where I've written an article called What is a menu.py and Why Should I Have One? So if you don't have a menu.py file in your .nuke folder by default, it's pretty easy to create one. You can just right click, choose new text document and type menu.py. You'll have to delete the .text because we want it to be a Python file, not a text file, and hit yes on that. And then we can open this up. So I'm using Sublime Text as my IDE. To install any Python file, all you have to do is copy paste whatever the file is into your .nuke directory. So I'm going to drag all those in here. And you'll notice the knob_scripter.py. This is the Python file that we want to import every time Nuke opens. So to do that, let's go back to Sublime. The first line that we should write in here is import Nuke. Python is made up of a bunch of different modules and it comes with a standard library of functions and things you can do with it. But to do any specific Nuke functions like create a node perhaps, we need to import the Nuke module, and this is written by Foundry. So to install Knobscripter, we just have to import it like the way we do with the Nuke module. And we can do that by importing the name of this file itself. So let's type import Knobscripter. I find it best to copy and paste the name of the file, and that way it ensures there's no spelling errors. Let's save our menu.py and open up Nuke. So now that Nuke's open, we can access the script editor by right-clicking and going Windows, New Script Editor. And this is the vanilla script editor where we can type any code and run it directly in Nuke. We just installed Knobscripter though, so let's use that. Notice the difference in syntax highlighting and a few different options up here. I much prefer Knobscripter just because it's a lot easier to read the code and has some fun extra features. So as you can see, installing other people's Python scripts is super easy to do with just a little bit of code. This alone opens up so many possibilities for new, time-saving functionality in Nuke, so I would highly encourage you to look through Nukepedia's archives and install the ones that sound interesting to you. Now that we have Knobscripter installed, we can write some code ourselves. As we're short on time, we're going to be moving pretty fast here, but I want to show you what's possible with just a few lines of code. So a real-world example of something that I do 99% of the time is attach a blur node to a Roto Node whenever I create one. No images captured by the best camera in the world with the best lens in the world will be a perfect pixel sharp, so neither should our roto shapes. By default, the O hotkey creates our Roto Node. When we hit it, you can see it outputs the nuke.createNode roto code. Input, output. We can change that hotkey to absolutely anything we like. and it's often best practice to build upon existing functionality so we don't have to relearn things that have been baked into our muscle memory. To do almost anything in Python, we need to write a function. Kind of like how Gizmo wraps up a collection of nodes to perform specific tasks, a function holds all of your code and groups it together, and then that's executed to perform specific tasks. So to write a function, you simply have to define it, and we can define a new function by typing def. Now let's give it a name. Call it RotoBlur shortcut. We follow the name of the function by open close parentheses and then a colon. Now let's add one line of code to our function. We can type print and then open quotes. My code is working. Great. Now if we run our code, which you can do by clicking this button up here, or you can see the shortcut is Control Enter, nothing happens, it just stays here. To run our code, we have to call our function. And to do that, we can highlight the name, including the open close parentheses, copy paste, and now let's try run this. From here on, I'm just going to use the Control Enter shortcut because it's easier. So now you can see the result is my code is working great. So we've defined our function, and inside our function, we've got instructions for it to do, and then we're running it. Super simple, right? So what's with these parentheses? Well, these will hold arguments, which we can demonstrate right now because we want to add our function to one of these menus on the side here. Kind of like how there's different ways to achieve the same result when compositing, the same actually applies to programming. And the easiest way to access an existing menu in Nuke is to add it again. So let's add some more code down here. And this looks more intimidating than this for sure, but I assure you it's pretty easy to understand. So see how each one of these functions has an open close parentheses and it's got things in between. Let's go through this one by one and see what this is going to do. So we're finding the menu nodes, which is what this is called here. Then we're adding that menu again, the draw menu, which is this guy here, and we're going to put it in here just because it's where the roto already lives. Then we're adding a command to that menu, and we're giving it this label, create roto and blur node. Then we're going to be running our function, roto blur shortcut. We define the hotkey for that, and then we're going to give it an icon. So this add command function is exactly the same as running the RotoBlur shortcut function, but part of the add command function has all these different arguments to tell it to do other things. So if we highlight this, and I'm going to use my Control Enter shortcut once again, you can see the script editor outputs this result, menu item. So if we go into here and go all the way down to the bottom, you can see we've got create roto and blur node, just as we've labeled it here. We can see our shortcut is O, we've got our icon. So now in our node graph, if I press the O hotkey, my code is working great. Let's do it again. It's still working great. And that's because every time we've pressed this O hotkey, we're running the RotoBlur shortcut now. So let's go ahead and change this RotoBlur shortcut to actually do what this code should do. So I've cleared the output window here just so we can have a fresh start and see exactly what's going on as we change this code. Before I start to type any new code, I usually like to think about the individual steps that it needs to do. So right now, our goal is we want to press the O hotkey to run the menu item, and it's going to create a roto node, it's going to create a blur node, and maybe it can change some values too. So let's start off with the node creation. We want to create a roto node and a blur node, so we can do that with 2 lines of code. Remember, the first line of code we saw was nuke.create node. So this is using the create node function from the Nuke module. And inside here, let's create a roto node. Same thing, we can create a blur node. And so we only want one indentation for both of these lines of code because we only want it inside this RotoBlur shortcut function. And we actually don't want this RotoBlur shortcut function here because every time we run this code, it's going to run this and also add the menu item. So let's delete that. I'm using Control Enter once again to run the code. Its output, there's no errors. So let's click over here and press O. There we go. It's done exactly what we want. So the next steps that I would normally do is set the output knob to RGBA, and I would set my blur node value to 2. Although this kind of defeats the purpose if we press the shortcut, but we still have to change these things. So let's automate that as well. To do that, we can just put a comma to add another argument, and let's type the knob name, which is output. But you actually have to hover over and see what the bold word is in the tooltip. That's the real name of the knob. So let's do output. Let's type RGBA. And for the blur node, we know the knob is called size. So let's do comma size. So knob name 2, which is the value. We'll highlight this and Control Enter to run. Let's try our O shortcut one more time. It's done exactly that. Clear this. We open our Roto Node, it's set it to RGBA, and our blur is set to 2. Now, if we're doing a few other things here, it might be a little bit annoying for so many new panels to open up. So we can actually add one other function that's included in the Nuke module to not open this properties panel at all. We can do that by adding the hide control panel function. So this just means this blur properties panel won't open at all. So if this blur properties panel doesn't open, it's probably good practice to just print this value on the node itself. So to do that, we can set a label. So in here, we've got our knob name and our value. So let's do another space. We'll type label because that's our knob name here. And we just need a little bit of TCL. So I have to create 2 quotation marks because we want to do a string. And in Python, a string just means text. So let's give our label open close bracket because we need that for TCL in the label. And we'll type value size. So value, the name of the size knob. Let's run this code again with Control Enter. Hit our O hotkey. And there we go. Just to be clear, I'll clear the properties panel. Let's do that one more time. And we only have our Roto Node there ready to go and start drawing our shape. And it will automatically be blurred 2 pixels. So let's go through our code one more time. To start, we're defining a roto blur shortcut function. And inside that, and we know it's inside because of the indentations, we're creating a Roto Node and we're setting the output knob to RGBA. Then we're creating a blur node and we're setting the size knob to 2 and we're giving it a label on the node of whatever the value of the size is. Lastly, we're hiding the control panel so it doesn't open over here. Then this long line of code is looking at the nodes menu. It's finding the draw menu and it's re-adding it again to access it. Then we're adding a command to it, create roto blur node, which is here. Whenever this is pressed, we're going to run the roto blur shortcut function, which we've defined here, or we can press the O hotkey. And lastly, we're going to give it this roto icon. It's the same as the roto node here. 4 lines of code. We've already customized Nuke to do what we want. It's super simple. However, there is one gotcha to this. If we were going to open a new instance of Nuke, which I'll do now, let's go to Knobscriptor. You can see our code is remembered here, which is great. But if I hit our O hotkey, it's just creating the regular Roto Node, which is what Nuke's default is. So how can we get it to remember this? Let's copy this. We'll open up our menu py and paste it in and hit save. So because this menu py file is loaded every single time Nuke is opened, it's going to look at all of this code. So it's going to define the roto blur shortcut and it's going to add our create roto and blur node menu item and add the shortcut here. This is a perfect example of why we imported the Nuke module. Because this is an external Python file, we have to import the Nuke module to be able to use the Nuke module like we have been down here. And that's really all there is to it. You've just made your first shortcut super easy, right? Let's try one more example. So there's 2 things that I frequently find myself doing with Python and Nuke. The first annoyance I have is any node like the scanline render node or perhaps the transform node, the shutter offset is set to start here, and here. In the real world, that's not really how camera shutters work. We usually, 99% of the time, will set it to centered. And we don't even have to write a custom function to do this. We can use one of the functions already built into the Nuke module called knob default. So we can grab our shutter offset knob, and by hovering over, you can see the name of the knob is shutter offset, not shutter space offset. And we'll set the value to centered. Let's run this code, create a transform node, and look at that, it's doing it by default now. Because we've written it like this, it's kind of a global knob default, so any node with a shutter offset knob, like perhaps the motion blur 2D node, has a shutter offset of centered. Although what happens if we want to keep all of the shutter offsets to start, but only change the transform shutter offset to centered? We have to get a bit more specific, and we can do that by just adding the nodes class here. So transform dot shutter offset. Now, because we've already set the global default, we're still going to get the centered shutter offset for everything else here. So we're going to have to redo that. So shutter offset, let's just set it to end to be something different. So any node with a shutter offset knob is going to be set to end, and any transform node with a shutter offset is going to be set to centered. Let's run this and watch it in action. So we'll create a scanline render node. You can see it's set to end. We'll create a transform node. It's set to centered. The last thing I want to show you is where the real power of Python comes in. So the last two examples, we've shown code where each line only does one thing. But where programming, and especially Python in Nuke, comes in handy and can be really powerful for an artist is by writing a couple of lines of code, but having it do so much more. So here's a snippet that I've brought in, and I use this one all the time to globally set motion blur values on every single node. So for example, you probably know what happens if you've got a big shot with heaps of CG characters or something, your Nuke script is massive and you've forgotten to turn motion blur on. Or maybe you just want it off as you work and you turn it on to render. As you can imagine, going through every single node and trying to not forget any node with a motion blur knob can be pretty tedious. So for example, let's just create a few transform nodes here. And I want to set the motion blur to on for each one of these nodes. So before I would have to go through each one, like go through my script and change this. But instead, I can just run this 3 lines of code, which is going to do that for me. See? Let's set everything to 1. Now I can see my motion blur, I can render it. If my script gets too heavy, I can just set that to 0, run it again. Every single node has a motion blur knob set to 0, and it's going to run fast. We haven't had to go through each one individually. It's just 3 lines of code, and it's done it for every node in the script. So to run through the code and how it's actually working, we're looking at all nodes in the Nuke script. And for each one, we're just assigning it a value of I. It's like X in algebra, basically. So what happens is it goes through one by one. It goes to the first node and it says, does this node have a motion blur knob? If yes, let's go to the next line. And let's set the motion blur knob's value to a value of 0, or 1, or 5, whatever you want. If you were to have a blur node or something without that motion blur knob, we'd look through all the nodes. So we've done this one, then it goes on to this one. Is there a motion blur knob? Nope. So it just doesn't do anything, and it goes to the next node, and it repeats and it repeats and it repeats, and it does it for every node in your script. So as I'm sure you can see by now, a few lines of code can do so many things in your Nuke script. Just a few seconds of writing out a few lines of code is going to save many minutes of searching through your Nuke script and can eliminate any possibility of forgetting 1 or 2 nodes and having to re-render all your pre-comps and everything again. I hope this brief introduction has shed some light on what's actually possible in Nuke with just a little bit of basic knowledge of Python and how that knowledge can improve your workflow. These 3 examples are the most basic of basic and already open the door to so many opportunities for both customizing Nuke to work the way you want it to work and also running some pretty labor-intensive tasks very quickly and painlessly. If you haven't already, you can subscribe to Ben's Comp newsletter at this link on the screen to keep up to date with everything I'm sharing, and also check out my blog for more quick Python tips. Of course, if your appetite has been whet and you want to learn some more about the fundamentals of Python and Nuke in an easy project-oriented manner, you may do so by taking my increasingly popular Python for Nuke 101 course. While there are various tutorials on Python and Nuke available, they all aim to outline certain parts, presuming you have a pre-existing Python knowledge or are purely theoretical and aren't particularly applicable to daily compositing life. As I did with Ben's Comp newsletter, I created the resource that would have greatly benefited me when I embarked on learning Python years ago, so you don't have to stumble through the same confusing path that I did. Python for Nuke 101 packs all the most useful and actionable information for complete beginners into 10 video lessons with an optional mentorship component at the end for continued learning. It comes with finished Python scripts, cheat sheets, and code snippets to reference whenever you need a refresher, and challenges at the end of every lesson to test and solidify your knowledge. Thanks to Foundry, by attending this webinar, 5 lucky people will gain access to this course for free. You can check out more about the course, including specifics on what you'll learn and Python scripts you'll create over on the website. And that concludes the demonstration part of this webinar.